In this waves and radiation topic in year 7, there's 7 things you need to learn. Transverse waves, longitudinal waves, wave speeds and how to calculate them, light and the visible spectrum, the electromagnetic spectrum, the uses and dangers of electromagnetic radiation, and reflection and refraction. So for the first lesson, we're thinking about how we can describe waves, and our keywords are transverse, amplitude, frequency and wavelength. And we'll think about what each of those means. Your first task is to write down as many examples of waves as you can think of. For example, waves in the ocean, light waves, sound waves. And our progression questions, which we revisit at the end, are: what is a wave? What do all waves have in common? And what is the relationship between period and frequency? And the type of wave we're looking at today is called a transverse wave. You can see it's got that wavy pattern. So choose one of the particles on the wave and watch it. How does it move? Which way is it going? And what word or words best describe its movement? Look very carefully. Hopefully you could see that the particle, the dot, was travelling up and down, perpendicular to the direction of the wave. So at right angles. The wave is going from left to right, but the particles are just going up and down. So what do waves transfer? When we're talking about waves, we're thinking about vibrations. What is being transferred here from the sun to the earth? Hopefully you could spot that it was energy that was being transferred, and it was by radiation when it's coming from the sun to the earth. We asked you earlier to think about examples of waves. Transverse waves can be things like water ripples, so the waves you might see in the ocean, light waves, and we can also show them on a rope or a slinky. When you're in school, we'll demonstrate that. Drawing a transverse wave. There are certain parts of transverse waves that have special names. Notice that the wave is equal. Okay? The high point of the transverse waves are called peaks, and the low points are called troughs. Peaks at the top, troughs at the bottom. And the wavelength of the wave is the distance between two matching points. So it could be from the very start to the very start of the next wave. It could be from each peak, so from the first peak to the next peak, or from the first trough to the second trough. The amplitude of a transverse wave is the height of the peak or the trough. So from the very peak to that line in the middle, or from the very end of the trough to the line in the middle. Notice it's not the whole height of that wave. Okay, it's from the middle to the far points. And our scientific definition for amplitude is the maximum displacement from the mean position. So that's the furthest it's going to be going from that line in the middle. That's that mean position. At the start, one of our questions was about period, and that's got the symbol T in science. That period is the time taken in seconds for one complete oscillation, and that's the same as the time it takes for a wave to pass a given point. Take time to read this and understand it. An oscillation is that one wavelength. So the time it takes for the wave to go back to where it started. We also had the word frequency at the start. So frequency, and its symbol is a small f in science. That's the number of oscillations in 1 second, and we measure it in hertz. Again, take time to look at this slide. The number of oscillations, the number of waves in 1 second. Now choose the task that you think you can best do. Your yellow task is answer the questions on water wave description sheet. Your green task is can you calculate the frequency and period of the questions on the hot sheet, and your super blue task is can you work out the period of a wave in a microwave oven and do it in standard form. Looking at our progression questions from the start. What is a wave? A wave is a way of transferring energy or information without transferring matter. So in the waves that we've studied today, if you remember, the energy was going, but the actual particle was travelling perpendicular up and down, not going across on the wave. What do all waves have in common? Vibrations or oscillations, and we can talk about their amplitude, wavelength and frequency. And number 3, which is quite hard, the relationship between period and frequency is that inverse relationship. So period is 1 over frequency, or frequency is 1 over the period. That's tricky. Take time to go back over this video, make sure you understand these basics before you move on.